Hello, you're with Colin and you're watching Grad School TV. This week we are looking at a problem which describes non-constant stock growth. Now, I had to think about this particular problem for quite some time because I was baffled by it. The logic just escaped me, and it turns out that somebody else in the course has had a similar problem. So I made this video to try and explain it to myself, but hopefully this will also explain it to this other person. And let's just call this other person Murray. Okay, Murray, so let's hope that this works as well for you in explaining it as it did for me. Okay, so what do we actually have here? We have a current dividend of 60 cents. Now, the growth rate for this dividend is meant to be 12% for the first 3 years. Then it's meant to be 5% indefinitely after that. Our required rate of return is 15%. How do we go about doing it? Well, let's have a look at Murray's worked solution first. We can just call that up here, like so. And what we have here is a lot of very scary looking numbers. It's a very nicely presented solution, but let's just home it right in on this line here, the second line down, which, well, it just looks scary. What we have here is a formula which is heavily based on the constant dividend growth model. So here's our constant dividend growth formula right here. And here it is appearing here, but in a slightly different version. And this, I believe, is where the sticking point of understanding is, right here. And I'll get to that in just a moment. This here looks like a fairly standard discounted cash flow formula. But let's think about these three numbers here and this second half of the formula as we go through, and remembering we're going to focus just on this bit here to try and understand what's going on, because I think, well, for me anyway, that's where the problem was. So let's see if we can explain this in a simple fashion. Let's have a look at our first 3 years of dividends. First of all, what we need to do is we need to create present values for the 3 dividends coming up in the 3 years, years 1, 2, and 3. So year 1, we have, if I double click in there, 60 cents right there, multiplied by the growth factor for the first 3 years of 12%, divided by the discount rate or the required rate of return, which is 15%. And that will give me a present value of the year 1 dividend at 58 cents. Applying the same logic to year 2, I get 60 cents times the growth rate squared this time for year 2, divided by the discount rate squared for year 2, which gives me the present value of the year 2 dividend. In year 3, we have exactly the same, except this time we are using to the power of 3 or cubed in order to get our 3-year discount rate or 3-year present value for that particular dividend. Now, these 3 values are present values, which means I can add them together. I can sum them. So if I sum all those values together, I get $1.71. Moving over now to the 4th year dividend, I'm going to use the constant dividend growth model formula, which is this one here, minus the little subscripts, so I apologize for that. I'm just trying to keep it very simple. Now, the bit where I fell over in my understanding was, what is this dividend value here? And why was there that extra multiplication? So just quickly going back to Murray's formula, why did this exist right here? Not quite sure. Couldn't quite figure out what was going on. So let's have a look going back here. What you have to remember is that the dividend has already been growing for 3 years at a particular rate. Then in year 4, it starts to grow at a different rate. So the actual value of the dividend is the value that it is, or the value that it's been growing at for 3 years multiplied by the new growth rate. So let's see what that looks like in terms of the formula. Okay, so we have 60 cents times the first 3 years rate of 12% to the power of 3 for the first 3 years. Now, because we're talking about year 4, we have 1.05. So we have to multiply that by 1.05. So you've got the first 3 years multiplied by the 4th year. Now we're thinking about that just heading off into the future forever. So that's our dividend value that we use to calculate this figure for. So what we're doing is we're calculating the price of the share at year 4, but we're not interested in that because we're interested in the price at year 0. So what we need to do is first of all calculate what that value is. So just going back to that again, we have 60 cents times the first 3 years of growth times the fourth year of growth divided by the discount rate minus the new growth rate, the K minus G part of the formula. That'll give us a value of the share, a price of $8.85. But that's not a present value, so we need to discount that back 3 years because we want to go all the way back here to year zero. So what we'll do is we'll take that figure, the $8.85, and discount it back. Now I've done that here in this cell. Double click there. I've taken $8.85 and divided that by the discount rate to the power of 3, which gives me $5.82. Now this is a present value, or these here, or this is the sum of these three present values. This figure here is now a price of the stock as a present value because it's been discounted back 3 years. So if I sum this figure and this figure, I get $7.53, which is the present value of the stock now, looking into the future where the first 3 years growth rate of the dividend is 12% and 5% after that. So just recapping, the tricky part I think is when you use the constant dividend growth model formula. At this point you need to know exactly what the value of the dividend is, and that's the hard part. Well, it was for me anyway. So finally, I'd just like to dedicate this video to my good friend Clayton Christensen, who's been doing all this fantastic work in recent decades on disruptive innovation and has been recently applying his thoughts to the field of education. And he'd just be thrilled to bits to know that students were out there asking questions and providing solutions using online methods and helping others to understand what on earth is going on. So thank you, Clayton, for your work. Really appreciate that. And hopefully this video has been helpful to, well, anyone who's taken the time to watch. You've been watching Grad School TV.